Welcome to video 12. Today we're talking about consecutive integers. Our goal for this video, given a consecutive integer word problem, you will be able to write let statements, set up an equation, and solve algebraically. All right, so let's first take a look at, well, what are consecutive integers? So consecutive integers are numbers that occur in chronological order. So numbers that are in order. So for instance, if I were to start a consecutive integer, so here's my example, at 5, the next number would be 6, and the next 7, 8, 9, 10. These are consecutive integers because they are in order. Okay, so now to develop a word problem, these consecutive integers would be unknown to us. So let's say I had my consecutive integers, okay, and I needed to set up let statements. So my first number would be x. So let's say 5 was actually the value of x. Well, to get to 6, what do you have to do to x, which is 5, to get to 6? Well, this would then become x plus 1. And then to get to 7, you would have to do 5, which is x, but we would have to add 2. To get to 8, it would be x plus 3. To get to 9, it would be x plus 4, because remember, x is 5. And to get to 10, it would be x plus 5. So when we're working with consecutive integers, depending on how many they want you to find, your let statements are going to be written in such a way that we would say, let x equal the first number. We would then say, let x plus 1 equal the second number. Let x plus 2 equal the third number. And so on and so forth. Let x plus 3 equal the fourth number. Okay, so that's how we would work with consecutive integers. Now, next up, we could also have consecutive even or odd integers. So let's say I only wanted odd numbers. Well, let's take a look. Is my x on an odd number? Yes. So that means I'm going to use x because I want 5. Now 6 is an even number, and I only want odd numbers right now. So x plus 1, that would be an even number, and I don't want my even numbers. X plus 2 is 7. Yep, that one works. X plus 3, well, that's the value of 8. I don't want 8 because that's an even number. And x plus 4 is 9. That's an odd number, so I want that. X plus 5 is 10, that's an even number. So what's happening is we want to skip all the evens, so we're skipping every other, okay, let statement. So here, if we want to have odd numbers, so an example here would be 5, 7, 9, that's what we just did. We would have to say, let x equal the first odd number. Then we would say now instead of x plus 1, we're going to skip that because that's even. We're going to go to x plus 2 equals the second odd number. And then to get to my third one, I would have to do let x plus 4 equal my third odd number. Okay, so you're skipping all the evens. All right, so let's take a look then. Instead of consecutive odd, now let's take a look at even. So in this case, if I match it up here, we want the even number. So my first even number would be 6. So I want 6, 8, 10. So what I'm going to do now, I don't want 5 at all. So my x is supposed to be the starting number, so I have to slide this down. So x is now going to be 6. All right, and that means x plus 1 is now an odd number, so I'm going to cross that off. So we have even, this would be odd, so we don't want that because we want the evens this time. X plus 8 is even, 9 is odd, so we don't want odd, and then 10 would be even again. So if you take a look, your let statements are actually the exact same for even as they are for odd. So you could say let x equal your first odd number slash even number. Let x plus 2 equal your second odd slash even number. And then your third one would be x plus 4, odd slash even number. Okay, so now we know how to write our let statements. Okay, this still might not be making a lot of sense to you yet, but let's go ahead, let's try one, and hopefully it'll all come together for us. Okay, so number 1, find 2 consecutive integers whose sum is 39. Okay, so if we take a look here, we want to have 2 consecutive integers. That means I'm going to need 2 let statements. Now, this is just regular consecutive integers, so I'm going to use x and x plus 1. So let x equal my first number. Let x plus 1 equal my second number. Okay, so I wrote my let statements. Now I need to set up an equation so that way I can solve. So let's reread the question. Find the key word that helps you set up an equation. And the key word is right here, sum. That means we're going to add them together. So x plus 1 equals 39. So I'm going to distribute to get rid of those parentheses equals 39. So 2x plus 1 equals 39. Subtract 1. 2x is equal to 38. Divide by 2. And x is equal to 19. Okay, now I found the value of x, but they didn't tell me to find x. They told me to find 2 consecutive integers. So I'm going to go back up to my let statements. Here I have let x equal the first. The first number was 19. So the second number, if I plug it in, 19 plus 1 is 20. So I always like to go back and put my solutions next to my let statements to make sure that I've answered the question completely. We can also write this in what we call set notation. So your 2 answers are 19 and 20. All right, so now these are consecutive, they're in an order, and they add to 39. Okay, let's go ahead now and try number 2. So here we go. Find 3 consecutive odd integers whose sum is 39. So now we want 3 consecutive, this time we want them to be odd. Now there's 3 of them, so we're going to need 3 let statements, and we want them to be odd, so we're going to go over here for our odd integers, and we're going to use these let statements. So let x equal my first odd number. Let x plus 2 equal my second odd number. And let x plus 4 equal my third odd number. So now we wrote our let statements, so now we need to set up an equation. So if we read carefully for a keyword, the keyword once again here is sum. So I'm going to add all of them together and set them equal to 39. X plus 2 plus x plus 4 equals 39. I'm going to have you pause the video now, find your value of x, and then find all of your consecutive integers. Okay, let's check our work. So were you able to get x equals 11? All right, if you did, then you should have gone back up and done 11. And then 11 plus 2 is 13. And then 11 plus 4 is 15. So we have our 3 odd consecutive integers. So 11, 13, 15. All right, let's take a look now at number 3. Find 3 consecutive even integers such that twice the smallest is 12 more than the largest. Okay, so let's start at the beginning. Let statements. Find 3 consecutive even integers. That means I need 3 let statements, and they need to be even. So that means I'm going to use my let statements for even, okay, which are these ones right here. So I'm going to start. Let x equal my first even number. let x plus 2 equal my second even number. And let x plus 4 equal my third even number. Okay, now that we have our let statements, now we need to set up an equation so we can solve algebraically. So this time we're going to have to read very carefully. It says, find 3 consecutive even integers such that twice the smallest is 12 more than the largest. So we're going to take this and we're going to transfer it into variables and an equation. So twice the smallest. So the smallest number is x, so we're going to go twice is 2x. The word is means equals 12 more than the largest. So we're going to add 12 onto the largest number, which is x plus 4. Okay, and now we can go ahead and solve. So the first thing I'm going to do is get rid of the parentheses. Then we can combine like terms, subtract the x over, and we get x to be equal to 16. So now I'm going to go back up to my let statement. So x is 16. 16 plus 2 is 18. And then 16 plus 4 is 20. And we have our 3 consecutive even integers. Okay, let's flip it over. We're going to try 2 more questions. Okay, so number 4. The lengths of the sides of a triangle are consecutive odd integers. The perimeter is 45 meters. What are the lengths of the sides? So here, I'm going to go ahead, the lengths of the sides of a triangle. So think, the sides of a triangle, how many sides are there? There's 3, are consecutive odd integers. So that means I'm going to need 3 let statements. And I have to use the one for the odds. So I'm going to go ahead and say, let x equal the first odd number. Let x plus 2 equal my second odd number. And then let x plus 4 equal my third odd number. Now remember, whenever they give us a picture, when in doubt, make sure that you draw it out. So let's make sure that we're covering all of our bases here. So here we have a triangle. This side is x, x plus 2, x plus 4. Okay, so now we need to set up an equation to solve. So we're going to look for our keyword, and that keyword is right here. We have perimeter. And we remember perimeter means we're going to add all the sides. So x plus 2 plus x plus 4 equals 45. So go ahead now, I'm going to have you pause the video and find your 3 sides. All right, let's double check. Were you able to get x equals 13? So that means one side of our triangle is 13, the other side would be 15, and the last side would be 17, and they're all odd integers. Okay, let's take a look then at number 5, our last problem. The lengths of the sides of a quadrilateral are consecutive even integers. All right, so let's start by, right away, when in doubt, draw it out. So here we have a quadrilateral, so that's 1, 2, 3, 4 sides. It says they are consecutive even integers. So if they're even, that means I have to use these ones over here. So I'm going to have x, x plus 2, x plus 4. So then the next one should be x plus 6. So instead of writing out let statements, I'm just going to put them in the picture this time. Okay, so now we have to set up an equation to solve. Twice the length of the shortest side plus the length of the longest side is 120 inches. Twice the length of the shortest side, so the shortest side would be x, so twice x, plus the length of the longest side, well that would have to be x plus 6, is 120. Now we have our equation. I'm going to have you go ahead, put this in the, go ahead and solve on your own. And let's see if you were able to get it. 38, 40, 42, 44. Nice job, everybody.